October 29th, 2022, 4:20 a.m., Sevastopol Bay, Crimea. Russia's Black Sea Fleet headquarters. Home port for dozens of warships. Protected by boom barriers, patrol boats, coastal defenses, electronic warfare systems, naval infantry security. One of the most defended naval facilities in the world. At 4:23 a.m., 6 surface contacts appear on Russian radar. Small, fast. Approaching the harbor entrance. Speed, 45 knots. Radar cross-section, minimal. IFF transponder, none. Russian patrol boats respond. Open fire. Destroy 3 contacts. Miss 3. The remaining contacts penetrate the boom barrier. 4:31 a.m. Multiple explosions. Admiral Grigorovich-class frigate. Admiral Makarov, damaged. Krivak-class frigate, damaged. Rescue tug, damaged. The attackers, Ukrainian-made naval drones. Unmanned surface vessels packed with explosives. Cost per drone, approximately $250,000. Cost of damaged ships, over $500 million combined. Return on investment, 2000.1. But whether these homemade naval drones represent a revolution in naval warfare depends on questions navies worldwide are asking with increasing urgency. This is Military Report, where we analyze the battles that change wars. Ukrainian naval drone. Various names: unmanned surface vessel, USV. Sea drone. Maritime drone. Ukrainian designation, Magura V5 and similar variants. Design: essentially a small speedboat without a pilot. Packed with explosives. Guided remotely. Expendable. One-way mission. Specifications: Magura V5 as example. Length: 5.5 meters. Width: 1.5 meters. Weight: approximately 1,000 kilo. Payload: 200 320 kilo explosives. Speed: 45 plus knots, 80 km/h. Range: 800 plus kilometers. Claimed varies by configuration. Guidance: Starlink satellite communication, GPS navigation, remote operator control sensors. Multiple cameras providing real-time video to operator endurance. 10 plus hours at cruise speed. Cost: $250,000 to $300,000 estimated per unit compared to traditional anti-ship weapons. Harpoon missile, $1.5 million, range 120 kilometers, 220 km. Warhead, Exocet missile, $1.2 million, range 70, 180 kilometers, 165 km. Warhead, naval mine, $30,000 to $200,000. Passive, requires deployment in target area torpedo, 1 to 5 million, depending on type. Submarine launch, typically Ukrainian naval drone, fraction of missile cost. Comparable warhead. Unlimited patrol time. Remote human control, allowing target selection. Reusable operator and control equipment. The economics are transformative. February 2022. Russia invades Ukraine. Russian Black Sea Fleet dominates. Ukraine has virtually no navy. Ships were scuttled, captured, or fled at war start. Naval warfare appears one-sided. Russia controls sea. Launches cruise missile strikes from ships. Enforces blockade. Ukraine can't contest naval superiority. April 2022. Moskva, flagship of Black Sea Fleet, sinks. Official Russian story: ammunition fire. Ukrainian claim: Neptune anti-ship missiles. Regardless of cause, major Russian warship lost. First indicator: Russian naval dominance isn't absolute. But Ukraine has limited anti-ship missiles. Can't sustain campaign against fleet using expensive missiles. Needs alternative. Needs something cheaper. Something that can be produced domestically. Something expendable. Solution: naval drones. If aerial drones work, why not sea drones? Technology exists. Commercial speedboat components. Explosives. Remote control systems. Satellite communications. All available. The concept is straightforward. Execution requires engineering and audacity. 3 questions. We'll answer them at the end. Can cheap, expendable drones genuinely threaten warships worth hundreds of millions of dollars, or is this asymmetric warfare success limited to surprise attacks that won't scale? How does Ukraine produce, deploy, and operate naval drones when it has virtually no navy, no naval infrastructure, and limited shipbuilding capability? And the critical one, does the naval drone revolution make traditional surface navies obsolete, or will countermeasures restore the balance between offense and defense at sea? The official narrative celebrates Ukrainian ingenuity and asymmetric thinking. True, but incomplete, because the naval drone campaign reveals vulnerabilities in modern naval warfare that every navy now confronts. Let's examine how Ukrainian naval drones actually work in practice. Development: mid-2022, Ukrainian engineers, some with civilian maritime experience, design naval drones, not from scratch. Adapted from jet ski hulls, small boat designs, available marine engines, commercial navigation equipment, off-the-shelf components assembled into military weapon. Key innovation: Starlink integration. SpaceX's satellite internet provides real-time communication with operator near GPS navigation, video transmission from drone cameras. All over satellite link, difficult for Russia to jam. The commercial service becomes military advantage. Production: small Ukrainian companies. Workshops: not traditional military-industrial complex. Decentralized production. Multiple designs. Competitive development. Government provides funding and requirements. Private sector provides innovation and production. The model is unconventional but effective. Initial testing, summer 2022. Prototype missions. Limited range. Technical failures. Learning process. But proof of concept validates. Naval drones can reach targets, can deliver explosives, can damage ships. The capability exists. Now scale up. First confirmed success. September 2022. Ukrainian naval drone attacks Russian logistics ship near Snake Island. Damage inflicted. Ship withdraws. Not sunk, but mission killed. Demonstrates capability. Russia notices, but doesn't fully appreciate threat yet. October 2022. Sevastopol attack. 6 drones. 3 penetrate defenses. Multiple ships damaged. This isn't isolated incident. This is coordinated attack against heavily defended target. Russian Navy realizes naval drones are serious threat, not nuisance. Strategic problem. Stay with me. What happens over the next 18 months reveals why naval drones succeeded beyond initial expectations. But the success isn't just technological. November 2022 through July 2023, Ukrainian naval drone campaign expands. Attacks on Russian patrol boats in Black Sea, landing ships near Crimean ports, reconnaissance ships operating near Ukrainian coast, naval facilities in occupied territories, Kerch Bridge, combined with aerial attack, success rate varies. Some drones intercepted, some miss targets. Some detonate successfully, but cause limited damage. Some achieve catastrophic hits, sinking or severely damaging targets. The campaign is iterative, learning, improving. Russian countermeasures. Countermeasure 1. Increased patrols. More patrol boats screening approaches to ports. Can intercept some drones, but can't cover entire Black Sea. Drones can approach from multiple directions. Saturation overwhelms point defenses. Countermeasure 2. Boom barriers. Physical barriers at harbor entrances. Nets. Floating obstacles. Effective against some attacks. But drones can sometimes breach or navigate around. Not impenetrable. Countermeasure 3. Electronic warfare. Jamming attempts. Targeting drone communications and navigation. Limited effectiveness. Starlink is jam-resistant. Drone operators maintain control even in contested electromagnetic environment. Countermeasure 4. Small arms fire. Sailors shooting at drones with rifles and machine guns. Sometimes successful at close range. But drones are small, fast, low-profile targets. Hit probability is low. And successful interception requires detecting drone early enough. Countermeasure 5. Relocation, moving high-value ships away from vulnerable ports. Dispersing fleet. reducing time in port, operating from bases outside drone range, effective but operationally costly, reduces fleet readiness and operational capability. None of these countermeasures provides complete protection. All impose costs. All require resources. All reduce Russian naval operational effectiveness. The cumulative effect is strategic. August 2023, Rapucha-class landing ship Olenigorsky Gornyak damaged in Novorossiysk port. Ukrainian naval drone penetrates defenses. Strikes ship. Severe damage. Months of repair required. The attack demonstrates, even after lessons learned, Russian defenses remain penetrable. This is Military Report. Real tactics. Real consequences. Key technical evolution. Evolution 1. Swarm tactics. Early attacks used 1-3 drones. Later attacks used 6 to 10 plus drones simultaneously. Saturates defenses. Even if most are intercepted, some penetrate. The probability math favors offense. Evolution 2. Improved navigation. Better autopilot systems. Waypoint navigation. Can operate with reduced operator input. Allows operator to control multiple drones sequentially. Reduces operator workload. Increases scalability. Evolution 3. Enhanced warheads. Initial drones had 200 kilo explosives. Later variants carry 300 pliskarse, shaped charges optimized for ship hulls. Increased lethality per hit. The damage potential grows. Evolution 4. Decoy capability. Some drones modified as decoys. No explosives. Just create radar signatures to draw defensive fire. Real drones follow while defenses are occupied. The deception multiplies effectiveness. Evolution 5. Extended range. Early drones had 300-500 kilometer range. Later variants claim 800 peace kilometers, puts entire Black Sea within reach. Targets previously safe are now vulnerable. The threat envelope expands. Evolution 6. Night operations. Initial attacks were often daylight. Later operations optimize for night. Harder to visually detect. Defensive fire less accurate. Success rate increases. The temporal dimension adds complexity for defense. Ukrainian operators discover naval drones are more survivable than expected. Russian countermeasures are less effective than predicted. The cost-exchange ratio overwhelmingly favors offense. Therefore, build more drones. Attack more frequently. Exploit the advantage. December 2023, landing ship Novocherkassk, destroyed in Feodosia port. Massive explosion. Complete loss. Multiple casualties. This isn't damage. This is catastrophic kill. Ukrainian naval drone achieves what conventional anti-ship missile achieves. At fraction of the cost. January 2024, corvette Ivanovets, sunk by naval drones in open water, not in port. Underway at sea. Approximately 60 km from Ukrainian-controlled coast. The attack demonstrates naval drones aren't just port attack weapons. They're open water threats. Any Russian ship operating in northwestern Black Sea is vulnerable. February 2024, landing ship Caesar Kunikov sunk near Alupka. Third major landing ship lost to drones in 4 months. Pattern is clear. Russian landing ships, critical for any amphibious operation, are primary targets. And they're vulnerable. The strategic impact is enormous. Which Russian ship type is most vulnerable to naval drone attacks? A. Landing ships. B. Patrol boats. C. Submarines. The answer reveals where Russian naval capability is most degraded. Keep watching. March 2024. Cumulative effect assessment. Russian Black Sea Fleet before war. Approximately 40 major surface combatants. Dominated Black Sea. Projected power throughout region. Enforced blockade of Ukrainian ports. Launched cruise missile strikes. Supported ground operations. Russian Black Sea Fleet current status. Relocated most major units to Novorossiysk, outside typical drone range from Ukrainian-controlled territory. Reduced operations in northwestern Black Sea. Abandoned Sevastopol as primary base for surface ships. Multiple ships sunk or severely damaged. Ships confirmed sunk or destroyed by Ukrainian attacks. Various methods including naval drones. Moskva, cruiser, sunk April 2022. Multiple landing ships. Novocherkassk, Caesar Kunikov. Others. Corvette Ivanovets, multiple patrol boats, various support vessels, ships damaged requiring extensive repair, Admiral Makarov, frigate, multiple additional vessels, strategic impact, Black Sea Fleet cannot operate freely in northwestern quadrant, amphibious operations against Ukrainian coast effectively impossible, submarine operations continue, but surface fleet ceded area control, Ukraine regained maritime access, enabling grain export corridor, Russian naval blockade collapsed cost analysis. Estimated Ukrainian naval drone expenditure 20 to 40 million, 160 drones. Estimated Russian ship losses $204 billion in replacement value. Return on investment 50.1 to 201. The economics are devastating for Russia. Ukraine achieves sea denial using weapons costing less than single Russian frigate. The asymmetry is unsustainable for Russia, but there's a limitation. Ukraine achieves sea denial, cannot achieve sea control. No Ukrainian ships patrol Black Sea. No Ukrainian naval power projection. Just defensive capability preventing Russian naval dominance. The strategic situation is negative for Russia, not positive for Ukraine. Neutral is relative victory for side that started with nothing. This is Military Report, where we break down the battles that change wars. Production and logistics challenge. Ukraine produces naval drones domestically. But how? No major naval shipyards operational. Limited industrial capacity. War economy with constrained resources, yet produces enough drones for sustained campaign. Solution involves Component 1, distributed production, multiple small companies. Workshops. Not centralized factory vulnerable to strikes. Decentralized network harder to disrupt. If one producer is destroyed, others continue. Component 2, commercial components, marine engines from civilian market. Hulls adapted from recreational boat designs. Electronics from consumer market. Explosives from military stocks. Assembly is custom, but components are available. Component 3, iterative design, not perfecting single design. Multiple competing designs. Market-style competition. Best designs get more orders. Innovation emerges from competition. Faster evolution than traditional military procurement. Component 4, foreign assistance. While drones are Ukrainian-made, some components likely sourced from allied countries. Starlink terminals from SpaceX. Some electronic components from Western suppliers. Navigation systems. The supply chain is international, even if assembly is Ukrainian. Component 5, volunteer labor. Some assembly work done by volunteers. Engineers donating time. Maritime experts providing expertise. The distributed model incorporates civilian participation. Cost to produce, estimated $250,000 to $300,000 per drone. Compared to Russian ship losses of $500 million per ship. Need 202,000 drones to equal cost of one ship, but only need 1 to 10 drones to sink one ship. The math strongly favors Ukraine. Operational model. Drones are launched from Ukrainian-controlled coastline. Inland waterways accessing Black Sea. Concealed locations to avoid Russian surveillance. Launch sites rotate to prevent targeting. Control is remote. Operators are not at launch site. Connected via satellite. Can be hundreds of kilometers away. Safe from immediate retaliation. This enables sustained operations without risking operators. Mission planning involves intelligence on Russian ship locations, weather assessment, route planning avoiding known patrol areas, timing to optimize surprise, multi-drone coordination for swarm attacks. The planning is sophisticated despite amateur production. Recovery? None. Drones are expendable. One-way missions. No need to return. This simplifies design and reduces cost. All weight and endurance can be devoted to reaching target and delivering warhead. Future development directions. Direction 1. Increased range. Longer endurance allows strikes deeper into Black Sea, potentially threatening Russian bases in eastern Black Sea currently considered safe. The threat envelope expansion pressures Russia continuously. Direction 2. Larger warheads, more explosives increase lethality. Ensure catastrophic damage rather than just mission kills. The escalation ladder continues. Direction 3. Autonomous terminal guidance, currently human-guided to target. Future variants might navigate final approach autonomously. Reduces vulnerability to communication jamming in final seconds before impact. Direction 4. Multi-role variants, not just explosives. Potential for reconnaissance drones with sensors. Electronic warfare drones jamming Russian communications. Decoy drones creating false targets. The versatility increases operational flexibility. Direction 5. Export potential. If Ukraine successfully employs naval drones, other nations will want similar capability, particularly nations facing adversaries with superior naval forces. Ukraine could export technology post-war, creates economic opportunity and strategic partnerships. Let's answer the 3 questions now. Can cheap, expendable drones genuinely threaten warships worth hundreds of millions of dollars? Or is this success limited to surprise attacks? Evidence overwhelmingly confirms, yes, cheap drones can threaten expensive warships, not just once, repeatedly, over 18+ months, against defended targets. After Russia implemented countermeasures, the success isn't luck, it's systematic capability. Why this works? Economic factor: drones cost 0.05 to 0.1% of target value. Can afford to lose 90% of drones and still achieve positive cost exchange. The economics fundamentally favor offense. Technical factor: small, fast, low-profile targets are hard to detect and intercept. Current naval point defenses weren't designed for this threat. Adaptation takes time and resources Russia struggles to provide. Operational factor: sea is vast. Can't defend everywhere. Drones can approach from multiple directions. Timing is chosen by attacker. Defender must maintain constant vigilance. Attacker chooses when and where to strike. Psychological factor: Russian crews are stressed. Constant threat. Reduced port time. Increased operational tempo for defensive patrols. Morale impact accumulates. Operational effectiveness degrades. The threat is real, sustainable, scalable. This isn't temporary exploitation of surprise. This is new warfare paradigm where cheap expendable assets challenge expensive traditional platforms. How does Ukraine produce and operate naval drones with virtually no navy? Through non-traditional approach, not relying on navy. Ukraine's military command recognized they couldn't rebuild conventional navy during war. Instead, develop asymmetric capability using available resources. The strategic pivot was essential. Civilian-military fusion. Private companies develop and produce drones. Government provides requirements and funding. Military provides targeting and operational employment. The model resembles startup ecosystem more than traditional defense contractor. Foreign technology integration, Starlink for communications, commercial navigation systems, Western electronic components. The international supply chain provides capabilities Ukraine can't produce domestically. Distributed operations. No central naval base required. Launch from multiple sites. Control remotely. Operate in network rather than hierarchical structure. The distribution provides resilience. Rapid iteration, design, test, modify, produce. Cycle time is months, not years. Failed designs are abandoned. Successful designs are scaled. The process is evolutionary and fast. Result: Ukraine developed naval capability from almost nothing in 18 months. Not conventional navy. Asymmetric sea denial capability. Sufficient to achieve strategic objectives. The innovation is organizational as much as technical. And the critical question: does naval drone revolution make traditional surface navies obsolete, or will countermeasures restore balance? Nuanced answer: surface navies are not obsolete. But they're challenged in ways not seen since aerial warfare emerged a century ago. Historical parallel: when aircraft appeared, many predicted battleships were obsolete. Partially true. Battleships declined. But navies adapted. Aircraft carriers became dominant. Integrated air defense emerged. Naval warfare evolved rather than ending. Current situation similar. Naval drones challenge traditional surface combatants. Force adaptation. Future surface ships will need integrated drone defense systems. Smaller crews reducing vulnerability to casualties. Increased automation. Better sensors detecting small surface contacts. Directed energy weapons for cost-effective drone interception. The adaptation is beginning. Development programs. Multiple navies developing counter-drone systems. Automated guns. Laser weapons. Advanced sensors. The technology will improve defensive capability. Tactical changes. Ships operating in higher readiness conditions. Increased vigilance. Better crew training. Operational procedures evolving based on Ukraine lessons. Strategic changes. Recognition that sea control in contested waters requires air superiority and shore-based support. Ships alone are vulnerable. Integrated joint operations are essential. But offense-defense balance currently favors offense. Cheap drones overwhelming expensive defenses. This may persist until defensive technology catches up. That process takes years, possibly decades. Meanwhile, naval drones are proliferating. Long-term, navies will adapt. Drones will be countered. But warfare will be fundamentally changed. Traditional blue water navy of expensive manned ships will decline. Future naval power will include large numbers of unmanned systems, distributed operations, reduced cost per platform, greater automation. The transformation is beginning. The quiz answer: which Russian ship type is most vulnerable? A. Landing ships. 40–50% of major losses. Landing ships are large, slow, must approach coast, operate in predictable locations, ports, beaches, limited defensive armament, high-value targets critical for amphibious operations. All factors make them optimal drone targets. 3 landing ships confirmed sunk. Others damaged. Russian amphibious capability severely degraded. Strategic impact enormous. Any Russian amphibious operation against Ukrainian coast is now nearly impossible. The capability loss matters more than monetary value. Patrol boats also vulnerable, but lower value. Submarines relatively immune, operate submerged. Frigates and larger combatants are threatened but have better defenses and operate farther from Ukrainian coast, typically. Landing ships represent perfect combination: high vulnerability, high strategic value, accessible targets. Their destruction achieved strategic effect beyond immediate tactical impact. This is Military Report. Subscribe to Military Report, because preparation defeats improvisation. February 2022 through March 2024. Ukrainian Naval Drone Campaign Summary. Estimated drones produced 200–400, exact number classified. Estimated drones deployed in attacks $150–300. Confirmed Russian ship losses 8–12 major vessels sunk or destroyed. Damaged vessels requiring extensive repair 15–25 Russian strategic response. Fleet relocation, reduced operations, ceded sea control in northwestern Black Sea. Cost effectiveness. Ukrainian expenditure 40–80 million. Production and operations. Russian losses 3.5 billion. Replacement value. Return on investment 41–125:1. Strategic transformation. Ukraine regained functional maritime access. Grain export corridor established. Russian naval blockade collapsed. Black Sea fleet forced into defensive posture. Russian amphibious capability effectively neutralized global implications. Every navy now developing counter-drone capabilities. Asymmetric warfare extends definitively to naval domain. Small nations can challenge naval powers with drone technology. Traditional naval procurement models questioned. Future naval warfare will integrate unmanned systems extensively. The naval drone doesn't make navies obsolete. It makes expensive manned ships vulnerable in ways requiring fundamental rethinking of naval strategy. The revolution is real, permanent, and proliferating globally. Was Ukrainian naval drone campaign strategically successful? Absolutely. Achieved sea denial against superior enemy. Neutralized Russian amphibious threat. Cost-effective asymmetric capability. Model for future asymmetric naval warfare. What would you have done differently? As Ukraine, earlier development would have prevented some initial Russian naval dominance. But given resource constraints, campaign was remarkably successful. As Russia, earlier recognition of threat and faster defensive adaptation. But organizational and resource limitations constrained response. The future of naval warfare changed in the Black Sea. Small, unmanned platforms challenging large manned warships. Economics favoring cheap expendable systems over expensive traditional platforms. Distributed operations replacing concentrated naval forces. This isn't just Ukrainian innovation. This is naval warfare evolution observable in real time. Every navy is watching, learning, adapting, because the lessons apply universally. $250,000 drones sinking $500 million warships. The math is clear. The implications are profound. The revolution is irreversible. This is Military Report. Subscribe, because we break down the battles that textbooks will study for decades. The homemade sea drones that defeated the Russian Black Sea Fleet, not through firepower, through economics, through innovation, through asymmetric thinking. The Navy that had no Navy, defeating the fleet that controlled the sea. With speedboats, explosives, satellite internet, and audacity, where garage workshops build weapons that sink warships, where commercial technology defeats military systems, where the side with no fleet wins control of the sea. The revolution happened quietly, one drone at a time, one ship at a time, until suddenly the Black Sea Fleet wasn't dominant anymore. And every admiral worldwide is asking, could this happen to us? The answer is yes. It already did. Just not to your fleet yet. Stay vigilant.